Okay, Longhorns, today we did some review of the parent functions, which we are going to continue tomorrow. However, we also need to review what the floor and ceiling functions are, since this is new to you probably. The floor and ceiling functions are step functions. In other words, the function rises in steps. So there's some values for y that get skipped in these types of functions. So this first step function is the integer function, also known as the floor function. This is a step function of x, which is the greatest integer less than or equal to x. The floor function is written in a number of different ways with special brackets, like you see here. You see special brackets, and right here you have some special bracket. This one has a line with a line underneath. That means floor. Or this one has just a double line, double bracket. It looks kind of like absolute value, but not, because you have these end pieces. And then this right here, another way to write it. These are all the same type of notation. So these just mean a step function. So here's an example of how we would evaluate a number if we're using the floor function. So examples would be 4.9. If we use the value 4.9, that equals 4. So at 4.9, if I go over here, 1, 2, 3, 4, almost to 5, 4.9, and I go up my graph, I should end up where y is 4, right here. Okay, so that's what that means. So we're going to use this floor function to evaluate this number right here, 4.9. So if we have a floor function, then we round down. Okay, if we have a ceiling function, this is this other function, then we're going to round up, and this is a little bit different. The difference here is that in the ceiling function, x is written with the brackets, with the bar across the top, okay? And sometimes this function is written with reversed floor function brackets, all right? So it's like the floor function brackets here, but in reverse. And other times it's written with a reverse bold-face brackets, just like this one, but in reverse. Okay, so you got to be careful of this one because it's different than this one as far as notation goes. All right, now in this one, when we do the ceiling function, we're actually going to round our number up instead of down. So this 4.9 now rounds up to 5. So when I go to 4.9 on my graph, 1, 2, 3, 4, almost 5, you're going to go up 1, 2, 3, 4. Now this one goes up to 5. You can see it goes up to 5 right here. So we're actually going to be rounding this number up if we're using a ceiling function. Okay, so negative 4.9, when I round that up, that's negative 4, because that would be the next higher number, negative 4, from negative 4.9. So don't get confused about that. Remember the negative sign, you're on the negative part of your number line, so as you move from left to right, the numbers get larger. All right, so that's basically all there is to these step functions for floor and ceiling. The main thing that you're going to need to know how to do is this right here. So make sure you know if you've got a floor function that you're going to round down, and if you have a ceiling function, you're going to round up. And you also need to know the difference between the notations. This notations have the brackets going in, or like this going in, and the ceiling has the brackets on top like this, or flipped backwards like this. Okay, so just make sure you know which function it is that you're working with. And that's really all there is on this page. Let's go ahead and move to page 43 of your notes. Go to page 43 of your notes, and we're going to review all the transformations that we learned in Algebra 2. All right, so I'm on page 43, and I'm looking at the review for transformations. And it says review transformations at the top. And then I believe in your book, this may be blank, a blank page. So what you're going to need to do is just fill in this information that's on this page with this information right here. These are the different kinds of transformations we're going to review, and these are the different things that they can do. But what I would like to do is map this out a little bit better for you to try to help you remember what everything does and where it goes. So, and which part of the function it affects, because I think that's really important. I don't think that just knowing that, for example, x plus c is shift left c units. I think we really need to look at all of the whole thing at once and see what happens. So I'm gonna kind of rewrite these notes a little bit at the bottom. But what I would like for you to do right now is I would like for you to go ahead and jot these down in your notes. So you can pause the recording. Take a few minutes to jot these notes down into your notebook. Okay, so I think negative f of x is the last one on here. Let me see. No, f of negative x is the last one. So you may need to scroll this up a little bit so that you can get all of the different transformations. Now, this is not complete, so this is why I want to go back over it again and do some more examples at the bottom. So what I'm going to use is I'm going to go ahead and use a quadratic, and I'm going to show you what all of the different transformations are that we can do, and what parts of the function are affected by certain transformations. All right, so first of all, we have this a, b, c, d at the top, right? And they're using CD, where last year when we learned transformations, we used A, H, and K. Okay, so what's different this year? Well, first of all, we're introducing B to you. So what kind of transformation is that? That's something new that you haven't learned before. And we're also introducing C and D in place of HK. Now, C and D and H and K are exactly the same thing. The only difference is what function uses them. Okay, some functions use CD, some functions use HK. It really doesn't matter. It's the same thing. So just keep that in mind when you're looking at these different transformations in different worksheets or different books that we look at, or different examples, because CD and HK are interchangeable. All right, so first of all, let's take a function. I'm going to take the square root, the parabola, the quadratic function, and I'm going to use that as my my basic function that we're going to apply all of these different transformations to. So the first thing I'm going to do is write my f of x equals a times, which I'm just going to use a parenthesis to represent times, okay? And then I'm going to put my b next. That's the new transformation that you haven't really used yet. B, x, okay, and then minus h. So we're going to use hk for this one. And I keep my squared in there because I'm using the parent function for quadratics. So I'm using this right here, this x squared. So a times b x minus h squared, and then on the end down here I'm going to have my plus k. Alright, so then what I'm going to do is I'm going to list all of the things that these different parts of the equation do. Alright, so first of all, let me explain something. When you are looking at these different parts of the transform, like the A and the K, for example, these transformations, the A and the K, these two transformations affect only the y value of your function. In other words, they only affect the range. So when you are making your table or you're looking at a graph, keep that in mind when you're looking at these transformations. A affects y values. K affects y values. All right? So inside the parentheses, we have our x. So guess what? B and H affect x values. So when I'm looking at a transformation, if I'm doing an A or a K transformation, those are vertical transformations. In other words, I am moving my y values up or down depending on what kind of transformation I'm doing. If I am looking at an x value, these values on the inside change the graph horizontally. So I'm going to be looking at the graph changing horizontally, or x becoming positive or negative depending on what kind of transformation we're doing. Okay, so vertical transformations, horizontal transformations, changes y, changes x. Okay, so that's, if you can remember that, that'll help a lot. All right, so let's look at what the different transformations are. All right, besides what they gave you at the top of the page here. All right, so if you have an A, transformation, there's three things that can happen. You can have an A that's greater than 0. And when this happens, this is a vertical, because remember we said A does vertical stuff. Vertical stretch, okay, by A, however many A's, okay, by A. All right, and then if the if the A is less than 0, this is a vertical reflection, because it's flipping the graph over up and down. Okay, so it would flip it over the x-axis, so to speak. Then if we have one that's between 0 and 1, 0 is less than A is less than 1, then we have a vertical compression. In other words, we are smashing it down like a pancake. So a vertical compression would be where we take the graph and we're making it wider. All right, so let's look at what happens with B. What happens with B is very similar to what happens with A, except this time it's a horizontal transformation. So we're going to look at what the B does to the graph. So when B is greater than 0, we have a horizontal, wait for it, compression. What? How can that be? Well, if you remember, whenever we have operations inside these parentheses, they always do the opposite of what we think is supposed to happen. Okay, over here with A, we had a stretch when A was greater than 0. But inside the parentheses, guess what's happened? We have a compression when B is greater than 0. Oh my goodness, let's get really confused. All right, just remember that insiders lie. And whatever you think is supposed to happen in here, it's really the opposite operation. So if B is greater than 0, it's actually going to compress the graph. Okay? When B is less than 0, it's a horizontal reflection. Now this time the graph is reflecting over the y-axis, or horizontally from side to side. Okay, so this would be a horizontal reflection. Now B, when B is in between, 0 and 1, when it's between 0 and 1, we have a horizontal stretch, just the opposite of what we think we're supposed to have. Okay, so this would be a horizontal stretch. All right, so let's see. Let's go ahead and look at the other transformations real quick. So we've looked at A and B. Now we need to look at H and K. All right, so you probably already have an idea what happens with H and K. So with H, this is a horizontal shift, because this is where we're moving the graph left or right. Okay, horizontal shift left or right, and it depends on what the value for H is. So what I want you to notice right here for H, this is real important to remember. The formula x minus h inside the parentheses is actually x minus a positive h. So this h right here is really a positive number. So that's why when you are looking at the transformation, it looks like the graph, well, the graph is moving to the right instead of to the left. When you see this minus sign, you think, oh, it should move to the left, but it doesn't. It moves to the right. So it's actually doing the opposite thing from what we're looking at. So you need to be aware that the reason why is because this h is positive. It's minus a positive h. So when we have one that's x minus a negative h, when h is negative, then this is when the graph moves to the left. But we don't see it written like that. We see it written like this, x plus h. And that's why it's so confusing, because we think, oh, it's a plus, so it's moving to the right. But that's not the case. It's actually moving to the left. So just keep that in mind. Hopefully that will help you remember that. If that doesn't help and you can't remember that, just remember that insiders lie. So whatever's happening inside here is always the opposite of what you think it should happen. All right, just remember that, and that might help too. All right. Now the last one is K, and let's take a look at K. What K does is K is a vertical. Remember we said anything outside the parentheses affects Y, which would be a vertical shift up or down. Okay, up or down. Oh, and this one up here, the horizontal shift is right or left. Okay, so that's a horizontal shift, right or left. K is a vertical shift up or down. Vertical shift up or down, and K only affects Y. Okay, K only affects the Y value. All right, so those are all the transformations. We have A, B, H, and K. This could also be C, D. All right, just so you know. And some functions we're going to do later on, you're going to see that sometimes we use CD instead of HK, but it doesn't matter. It's the same thing. All right, they do exactly the same thing. All right, so we have A, vertical stretch. A is less than 0, vertical reflection. A is in between. It's a fraction. That's a vertical compression. When B is greater than 0 or positive, it's a horizontal compression. When B is negative, it's a horizontal reflection. When B is in between 0 and 1, it's a horizontal stretch. H is a horizontal shift, right or left. Okay, and remember why. The reason is because H is really positive here. This is minus a positive. This is minus a negative. So keep that in mind. This really tells you which way it's going for reals. Okay, and this is x plus h. All right, this actually means x minus a negative h. All right, so then we have K, which is a vertical shift up or down, and that's basically all of the transformations that we're going to do. And we're going to work on pages 44, 45, and 46 in class, and also 47 and 48 we will also do in class on Friday. So we'll finish up this week with transformations. If you have any questions, please bring them to class with you, and I will do my best to answer all the questions you have. Be prepared for the gallery walk we're going to do on the parent functions first thing tomorrow, and should be fun and be nice to get out of the room and walk around for a little bit. So when we come back, we will work on transformations. Have a good night, Longhorns.